It hasn't worked, but it's okay. It will take a second. Okay, good. So this institute called CITRIS, it's actually a partnership between Berkeley, Davis, Santa Cruz, and Merced. You know, that's the sort of the UC solar system, if you wish, out there with with those 4 planets out there. Just kidding, as you know. For those of you that don't know me, you shouldn't take everything I say at face value. Let me just tell you about why we put this institute together. You know, in 2001, there was a sense that everybody was talking about this sort of much ballyhooed convergence of bioinfo nanotechnologies. And that's certainly, by the way, a meeting like today's is really about that convergence. You know, the fact that it's already happened to such a great extent that you can actually talk about cognitive computing is a tribute to that. But the faculty, and actually the Industrial Advisory Board of the ECS department at that time, came and told us that you really do need to think not just about technologies and throwing them over the wall and expecting them to change society, but to really start thinking about what society needs and think about what the technologies are that are required for making this change. So this term, interest of society, is of course a big word. We in turn sort of parse that into interest in the area of energy, delivery of education, transportation. So this was all hatched in 2001 where these California blackouts were gradually beginning, and so that was sort of one of the big motivators. Of course, now it's taken on a life of its own. Monitoring of the environment. So energy and environment, as you all know, is just simply the most pressing problem of our times. But we'd gotten started thinking about this. Emergency response, earthquakes, floods, disaster relief. And by the way, one of the faculty that are involved in CITRIS was just called to go work out the details of the MacArthur maze, you know, and he'd been working on what to do with bomb damage on buildings. You know, civil engineer called Hassan Astani, and simulations of bomb damage on buildings is actually a computing agenda. And of course, that's sort of what this tanker truck was, right? It was a big bomb that sort of destroyed parts of it. The delivery of healthcare. So this is not so much the bug to drug, but really thinking about how you can use information communication technologies to deliver healthcare. So what I'm going to do now is to just tell you a little bit about this is, you know, people have these sort of mission slides about what they do, but let me not talk to the slides. But you know, the University of California is the brass that runs the University of California are all Bell Labs alumni. No, not all, but a large number of them are Bell Labs alumni. So our president, Dines, is Bell Labs alum. Our chancellor, Bergenow, is a Bell Labs person. Steve Chu is Bell Labs. And now the chancellor of Merced, Steve Kang, is also a Bell Labs person. So, you know, and so I think that really a lot of what was going through their minds was to create an atmosphere not unlike that of the great industrial labs of an earlier era, which created this ecosystem. So it's not to say that there aren't great industrial labs today, but you know, it's I think that IBM, Bell, Xerox, a lot of them, you know, it was easier to have these industrial labs when you had essentially monopoly power because you could allow for unfettered research. So now I think it's just harder. It's just a fact of sort of where the economy has taken us. But we would like to have something like those now. And that's really the agenda. It's not, and it's actually to support the industrial labs in any way that we can, because they are still wonderful institutions. So that's what goes into this. And so our story is that we really do try to create this ecosystem. Those are, you know, each one of these campuses, they go Merced, Santa Cruz, Davis. Berkeley is the only one where we don't really have a building still, so I have a picture of the Campanile instead. But there's a building being built on the north side of campus. And I must say the founding corporate members stuck to us. And I want to plug these companies that have supported us because they've stuck through. So they advised us to start it. And the founding corporate members were the Industrial Advisory Board that encouraged us to get started. And they stuck through supporting this research through some very tough times, you know, 2001 through 2005. And they've really been with us in terms of formulating this agenda, and so it's a list of a lot of the companies that are here today too. So what do we do in CITRIS? I think the main business in CITRIS is that there's a model of doing research in Berkeley where you have, and the University of California I should say more generally, where you have lightweight research centers. There are centers that can form and unform in some ways after a 5-year period. So it's 5 years, they hold together by 5 years, that's roughly as long as it takes to get a PhD. 5 to 10 faculty members, 50, 75 graduate students, almost always one large grant of some kind, and 2 or 3 very tight industrial partners. So that's sort of a formula that has worked on this campus. And so what we've tried to do is to try to help that get going. And in these 5 years that CITRIS has been in operation, we've added all the things in blue are the ones we added. So the center, of course, that's supporting this event, which is BISC, of course, pre-existed, which is why predated, I should say, the creation of CITRIS, and that's why it's in black, as is BSAC, Berkeley Wireless Research Center, etc. And so, the issue has been, we've helped incubate these centers, if you wish, and they go through a process of vetting. We help them find the right partner, and they're all over the map. There's some of them in nanomechanical systems. That's COINS, the Center for Biophotonics. There's wireless foundations about spectrum utilization, and almost always they the technology has a social component. So in the wireless foundations, it's about spectrum utilization policy, influencing the FCC to think about what it does, both with especially with unlicensed spectrum, but also about what you do with licensed spectrum in the sense of making available licensed spectrum to work on this. And the model had always been that we announce these things, announce them as centers when there's some large federal grant that comes along, and these industry partners. Last year, David Patterson, partly to make a case for the lack of federal funding for computer science research, put together this thing which he called the RAD Lab, to be reminiscent of a RAD Lab of an earlier era, which came exclusively with industry funding. But since that time, there's many others, so maybe if we're thinking about modifying the model to include all industry-funded opportunities in the future. Let me give you a sense of the impact of some of the centers that have been off and going. So one big project, and of course, as you know, this particular event, as well as tomorrow's Future of Search, is co-sponsored by Horst at LBNL and us at CITRIS. Actually, we like to think that CITRIS includes, in addition to the 4 UC campuses, LBL. So consider it a partner. But you see, they have launched on a major initiative called Helios in terms of using the energy of the sun. And that, in turn, has led to a smart multi-campus smart infrastructure initiative. So that's an example of one of the solar cells that comes out of Helios. And I think this actually comes from Davis. It's a particular, and so that agenda about sort of using better solar cells and using the desert areas, as well as the Energy Biosciences Institute, are 2 different things that have come out of this. This is Greg Fenwes out here from the Civil Engineering Department, instrumenting the Golden Gate Bridge for measuring the vibrations of the bridge. In places like Hong Kong, you need to shut down a bridge when the typhoons come in, and so you need to monitor them. The last one, which I'll spend a little bit more time on, is a very Berkeley project, which is the notion of using technology to improve developing economies. And that's led by Eric Brewer, so I'll tell you a little bit more about this next. So one success story that is frequently attributed to CITRIS is this sort of smart dust and wireless sensor network agenda. And this week's Economist, of course, has got all this plastered all over it. These 3 Berkeley startups that came out of this, Arch Networks, Arch Rock, Dust Networks, and MoTiV were the 3 quoted in this article. Crossbow was pre-existing. And this little picture shows that in these 4 years, Berkeley faculty have basically sort of instrumented the world. I think that it's really not an exaggeration. That's the Chicago Fire Department on the left for letting people get out of buildings. Those are redwood trees that is condition-based maintenance of factories. That the picture in the upper right-hand corner is Intel labs studying the breeding habits of these birds off the coast of Maine, storm petrel. So go figure why Intel would be interested in ornithology, but they're actually interested, of course, as you can imagine, in long-lived sensors. That's forest fires, and that's the Golden Gate Bridge, and so on. So this, in turn, has, I think, is a small technology with a big agenda. So Forrester thinks that it is now a $20 to $40 billion market. That's the growth potential of this market. We think that the initial adopters of this will be process control industry. So Siemens, Emerson, Honeywell, they've all announced that wireless sensor networks are going to be their big product for these not for heating, ventilation, and air conditioning, but really on the process control. SCADA is what they call it, supervisory control and data acquisition systems. That itself is a $100 billion market, so that's what Forrester is basing its thing on. And they may be the lead adopters, and certainly this is one of the things that's off and running. And, in 4 years, so privacy issues were a big issue in the deployment of these. Let me tell you something about this project called Technologies and Infrastructures for Developing Regions. This actually began initially as a brainchild of Rich Newton, our former dean, and it's currently led by Eric Brewer. And the notion here is to use inexpensive cell phones and, in fact, to provide the infrastructure, deploy the infrastructure. It's just modify 802.11 infrastructure to be long-haul infrastructure. And the reasons that he first started doing this, so this is a deployment that's off and running in rural South India. That map there shows you where in South India it is. It's in the border of Tamil Nadu and Kerala. That's that little red district. There's a fantastic eye hospital there called Theni, but there are a lot of people just can't afford the time to walk there. As a result, their eyes can't be examined for cataracts. People go blind, and so on and so forth. It's a really completely disastrous situation. It's actually a nationwide phenomenon, but it's especially bad in rural India. And so what he has done is to take this modification of 802.11 technology to you got to modify the protocols. If you wait, sorry, that's my BlackBerry interfering with the wireless mic. To modify the 802. And what it does is it's an economical model to allow, and it's completely self-supporting. So the notion is, so why am I telling you all this? Development in the past has meant rich countries or rich people giving poor people money to become less poor. So the thesis here is fundamentally different. You give people the tools to get themselves, to work themselves out of poverty. Mohammad Yunus of the Grameen Bank and satellite phones and so on and so forth really came to this campus in 2002 and spread this gospel, which I think the faculty really, really bought into. And it's this notion of having small microfinance to let people adopt not the hand-me-down technology, but the brand new technology and improve their own lot, based on the sort of self-help model. So it's sort of uniquely West Coast model. Here are pictures of what it does. And what does it do for the technology? It really pushes some pretty interesting new directions in technology. Madeleine Plauché has worked on so illiterate populations can't use the keyboards, so you got to have voice recognition, language recognition. Of course, nobody is speaking a single language. And that people are speaking a hybrid of English words thrown into their native language. So most common translation systems, perhaps there's somebody here in this audience who can deal with a mixture of English words with these are Tamil words, that's what Madeleine Plauché does, is a real issue. And then gesture recognition. So the picture at the bottom actually shows you how they're training the system. And the reason she's holding a phone, it's a mock phone, is just that it's a realistic way for them to photograph how she recognizes gestures and what she says for training the system. That's examples of pictures of the antennas. And these are antennas in places with intermittent power and so on and so forth. So they're really interesting technical issues. And in fact, it's gotten to be so wonderful that ACM has a whole special interest group on emerging technologies for emerging regions, which had its first conference here. Microsoft, HP, Intel all have labs in India which are pushing this. And what's even more exciting is that last summer, they're doing almost 60 or 70 kilometer links in Accra in Ghana. And they're off in all these other countries as well, Rwanda and so on and so forth. Cybersecurity is a particular pet of mine. It's a NSF Science and Technology Center. Let me just tell you a little bit about the model of operation here. So we're talking about credit card numbers and identity theft. So what's the story here? So in November, you might have heard UCLA got broken into, and 800,000 identities were stolen off the UCLA computers. So on eBay, people, this is a real nexus of organized crime and hackers and so on and so forth. You can sell identities, especially if, my identity, for instance, would be $50. If it's somebody who had a little more money, it would be $200 maybe. But so $50 times 800,000 is $40 million. So at $40 million, you can see that organized crime can actually afford to invest in an attack which is not on the network as a whole, but is really customized to attack an entity. And that was the anatomy of the UCLA attack. And of course, you can do the forensics and figure out exactly where it goes and so on and so forth. And that was all done, and it's all a pretty interesting story. But what we've done in Trust, which is the Cybersecurity Center, is to produce a sequence of products which we put out, and we try to get adopted by Internet Explorer, by Google, by eBay, Earthlink, et cetera, in a model which, a model of technology transfer which we call NERF, which is non-exclusive, royalty-free. It isn't quite open source, but we try to give it away so that people can take it and customize it and use it any way they want. And there's 5 universities. So this particular one is all the things that they've done for essentially about password protection. So password hash is a browser extension. So the notion is, people just use 7 or 8 different passwords, and you use the same thing whether you're accessing your bank or your high school reunion. The problem is your high school reunion website might be easy to hack into, and if they're using the same password, then that's not so good. So the issue is if you can customize the password based on the site that you're going to, then even if that was intercepted, it could bleed over into something else. And that's what password hash does. Dynamic security skins is another example of something which provides a abstract art background, which is familiar, and tells you not to reveal your personalized data in terms of until you see a pattern. In terms of the statistics, by the way, the case used to be made that it's negligible compared with credit card fraud and so on and so forth. At the current time, the numbers are 15% of financial losses reported are due to identity theft and other versions of this, but the rest of the other 85% is growing linearly, whereas this is growing exponentially. So the chief security officers and the chief privacy officers of all these companies are finally all waking up to what needs to be done. So of course, one of the problems with this work is it's a cat and mouse game. So once you solve phishing, then they have something called spear phishing, which is a more adaptive version of this. You got to come out with attacks against spear phishing, which is timing attacks and so on and so forth. So it's the other thing is that working with the law school, there's a professor at the Stanford Law School actually, and what she does on these courses is working with the Attorney General's office to try to put companies out of business. And just like we got Al Capone on income tax charges, they try to get these people on EULA violation, which is end user license agreement violations. And so this is sort of the sport for these classes. So what do we currently doing in CITRIS? Jim Gray, who used to come to these meetings, I have to say, the BISC meetings, said you should just do a few things. So we asked him what a few meant, so he said 2. I said, how about 3? But the 3 became 4. So those are the 4 things that we work on. Energy in the environment, and it's a little too detailed to go into. So you've all heard about biofuels and this notion of all kinds of biodiesels. And again, Berkeley and LBL have won this thing from Beyond Petroleum called the Energy Biosciences Institute. They're going to produce all kinds of exotic fuels. So imagine pulling up to a gas station where you have biodiesel, and then you have something which comes out of cellulose and something that comes out of other products. And the question is, The engines, on the other hand, manufactured by General Motors or Toyota or whoever else, are used to burning either your three varieties of fuel. So can we not think about a cognitive engine which sort of figures out what the fuel is and burns it efficiently? And that's when you use those computers up at LBNL to figure out how to optimize the engines and to actually tweak them in order to burn them more efficiently. And that's sort of what we are doing here. Sensor networks, putting them in infrastructures is a big agenda. Service sciences and healthcare, I'll just tell you a little bit and I'll get off the stage at that point. So our colleagues at IBM really got us thinking about services, and this is due to Jim Sporer from IBM Research. It's a picture that a lot of you may have seen. It says that even in countries like even the BRIC countries, there's a large growth in the services, and certainly even though one can quibble about numbers, really what this is about is that information communication technologies is changing how we deliver services. A lot of this is being manifested in the outsourcing that you hear about into what goes to the software companies, what Infosys does, and so on and so forth. So the question is, how can we teach our students about how they build services? And what we've done is, even though we are primarily a research operation, we've tried to put together something which neither a business school nor a engineering school nor an I school, an information school teaches, which is a curriculum on service sciences, very much to try to fill in this soft spot. It includes things like document engineering, which is much more traditional, but it also includes things about how do you think about, the current time, the way a company like Infosys works is, if there's somebody from Infosys in the room, you can tell me differently, but the way it works is they'll go consult with somebody, and it's a customized solution for how they deliver the information communication technology services for a specific client's needs. So the question is, can this be done according to some templates, and can we sort of work this? And this is certainly an intelligent systems agenda, which is much more than a ad hoc agenda. We're initially focusing on healthcare as this circle should have been around healthcare. So the notion is, it's the least computerized of all these sectors. And so the reason you should worry, of course, is every time you go and have a lab test, your lab results are never where you want them, and you can never get them. And the numbers are staggering. We spend $2 trillion in healthcare, 35% on lab tests, $600 billion, and 70% of that is on paperwork moving around. So that's $400 billion. So you just were able to trade PDFs on cell phones and to do so securely and privately. Not only would you have your test results where you wanted it, but you would. So the Palo Alto Medical Foundation, the Veterans Administration are good partners for thinking about this. So the last area is about this electronic medical records implementation of this infrastructure, but also telemedicine. So telemedicine is an area that has come, and the reason it has come is not only because of this robotic surgery kind of picture that I have here, but because of elder tech. There's a sense that if you can use technology, and that's, I think, it's a big place that this cognitive computing agenda would have a huge impact. A lot of the money that we spend in healthcare is in the last 2 or 3 years of a person's life, and in fact, the bulk of that money is spent in managed care facilities, which people don't actually like. If they could stay at home, they'd be a lot more comfortable. And of course, we are going to be an increasingly graying population. So if you can bring to bear technologies, digital post-it notes, fall detectors, all of these technologies are going to be great. And so, in fact, a few weeks ago, Andy Grove, the former CEO of Intel, he gives this talk based on what the business plan for Intel Digital Health is, called Shift Left. And, that's not a sort of a Berkeley slogan, even though you can imagine that this might be one. It's really about using the most common technologies. So use the cell phone, use the most commodity technologies to provide solutions for healthcare rather than sort of really souping up super fancy solutions. And those are the technology agendas that go into it. So we have colleagues that are doing MEMS chips for lysing blood cells, doing pre-symptomatic diagnosis. Again, there's a social agenda. There's a colleague of mine called Bernard Boja who's put together a dengue fever chip, which is, done. Okay, good. That's it. I'm ready to quit at this point. This was my last slide, and I'm happy to stop.
Good. Thank you so much, Shankar.